Well, howdy students, this is going to be Unit 9, Part 3, which we are going to move into a new field, covalent bonding. So far we've discussed Lewis dot structures, octet rule, looked at ionic bonding, and then we looked at metallic bonding, and now we're going to look at the third type of bonding, which is covalent bonding. And if we look at the image below, we'll see that we have two elements coming together, but they're both nonmetals. And so what's happening is we are having to share electrons rather than transfer. So we're not going to have ions here. No pluses, no minuses, just sharing of electrons cooperatively. So we got to go over what a covalent bond is, of course. It occurs when a pair of electrons is shared between two atoms. It would be our third type of bond that we're learning about in this unit. Often between two or more nonmetals. So let's refresh again. You have a staircase on the periodic table. The nonmetals are above the staircase with the inclusion of the element hydrogen. So a single covalent bond is going to be two atoms that are shared in a single pairing. So if we look at hydrogen below, you'll see that there are two dots. Hydrogen is 1A. The other hydrogen is 1A, of course. They both have one valence electrons, and what we'll find is that we can share to form a single bond. We can have a double bond, which just means that instead of a single sharing of electrons, we have a second pair of electrons that are shared. And then we can also have triple bonds, which is when we have not just one, not just two, but we have three pairs of shared electrons. So what we're going to see when we draw these, we're going to use lines. We can have a single bond, a double bond, and even a triple bond between two elements. Each line represents two electrons. So I have my students write that in. Each line is going to represent two electrons. So really there's two electrons that are sitting in there. So if we had a double bond, we would have 4 electrons. And so I want to go back to this real quick. If we were drawing this out, what we would see is an image like this. Hydrogen, oxygen would have the double bonds, plus you'll see those dots that are hanging out. We call those lone pairs, and we'll talk about those more. Nitrogen would have 3 bonds, and each would have a single lone pair of electrons. Lewis dot structures are useful for representing these covalent bonds. And so what we're going to learn today is how to draw the Lewis dot structures for shared electrons. We cover these last because they are a little bit more complex, and we're going to spend quite a bit of time doing these. So here's the first one. Hydrogen has 1 valence electron apiece. And remember that hydrogen follows the duet rule, not the octet, which means it only needs 2 electrons to be satisfied, like helium. So here's the first. We're going to go ahead and bring these guys together to form a single bond. So what I tell my students to do in class is go ahead and draw the 2 dots in the first image, and if you want to draw a second image, you're going to draw the single bond there. So again, what I tell my students is go ahead and draw both here in your notes. That way you can see how the single line represents the two shared pair, or the shared pair of electrons there. And I want to note that this is the correct structure. This is what you want to draw officially. The next one, we have chlorine. Each has 7. And remember that chlorine is going to obey the octet rule, which would be 8 electrons. So we just got to make sure hydrogen is kind of the exception there. Each one has 7 dots. Go ahead and fill those dots in. And what we're going to have is chlorine forming a single bond. So again, if you want to, you might want to draw the shared pair between the two. Oxygen is in group 6A, and they're both trying to achieve the octet rule, so they're going to come together to form a double bond. And then last, we have nitrogen, which was also on the last page. Nitrogen comes together to form 3 bonds, a triple bond. Nitrogen is in group 5A, so they're going to share 3 pairs to get to 8 apiece. And before I move on, I want to show you, go back up to hydrogen. This hydrogen has the 2 that it needs, and so does this hydrogen. This chlorine has the 8 that it needs, and so does this chlorine. This oxygen has the 8 that it needs, and this oxygen has the 8 that it needs. This nitrogen has 8, and this one has 8. So by sharing, we can see that everything is satisfied with either the duet rule for hydrogen or the octet rule for all others. Okay, we're going to move on to the rules for writing electron dot structures. There are 5 different rules. We're going to go over each one of them. They're listed in your notes. I would use them as a reference. And then we're going to work through the examples. And there's going to be spots in the video where I'm going to ask to pause, and I want you to actually try to write the structure out yourself first, and then check your answer. Okay? So we'll do the first couple together, but then I'm going to ask that you pause the video and work to see if you can get the correct answers. First rule, and we're going to be working on the rule for H2O. So in your notes, we're going to be on H2O. So I'm going to go through the rules. You might want to hang tight until you actually see the final drawing for H2O. So the first rule, we're going to add up the total valence electrons from all the atoms in the compound. Okay, so this is going to be for an element that has more than just 2 elements bonded together in a covalent bond. Don't try to keep track of which electrons come from which atoms. If you're working with an ion, we're going to have to add or subtract the electrons to account for the charge. Okay, so let's do the example for H2O. You don't have to write anything yet, but I'm going to walk through the rule. So I'm going to add up the valence electrons. So for hydrogen, it's found in group 1A, which is 1 valence electron, but I have 2 hydrogens, so that would be 2 valence electrons total. Oxygen is in group 6A, which contributes 6 valence electrons, and we only have 1 of those. So to get a total, I'm going to add them up, and I'm going to get 8 valence electrons. So step 1, figure out how many valence electrons you have to work with. Step 2, put the element that you have the fewest of as the central element. Make it symmetrical. So here we're just going to be putting things in a spatially correct pattern. So what you want to do is spread out the elements. So for H2O, I have 2 hydrogens, 1 oxygen. Well, symmetrically, it's going to make the most sense if oxygen goes in the center. So that's how we would draw it. 1 hydrogen on each side. This is going to take some time. Some of you may have drawn it like this. That's okay. Just make sure that oxygen's in the center so that it is symmetrical. Rule 3. Use a pair of electrons to connect a pair of electrons between each atom. So this one, you're just connecting elements. So this is my favorite rule. All you have to do is connect the elements with a single bond. So what you've done here is you've actually drawn 2 electrons there and 2 electrons there. Okay. Rule number 4. I would star this. This may be one of the trickier rules. Arrange the remaining electrons to satisfy the duet rule for hydrogen and the octet rule for all remaining atoms. So once we have this guy, I need to make sure each element has what it needs. Okay, well, hydrogen here has those 2 electrons that are shared. This hydrogen has 2, and remember, hydrogen follows the duet rule. But what about oxygen? Currently, oxygen only has 4 drawn around it. So what I need to do is come in and make sure that oxygen has 8 total electrons for the octet rule. And now it does. So now we can move on to Rule 5. Rule 5, count the number of electrons represented in the drawn molecule, and we got to make sure that it matches step 1. So 5, what I tell the students to do is draw an arrow up to rule number 1. You got to make sure Rule 5 matches Rule 1. If too many electrons are represented, a couple things happen. We might need to draw a double or a triple bond. In that case, when we draw a double bond, we have to remove a pair of electrons from each element taking place in the bond. And I will show you an example of that in just a second. So, if I'm counting the number of electrons in the molecule that I've drawn, I've got 2 here, 2, 2, and 2, which makes a total of 2, 4, 6, 8. Does this match step 1? And you had counted 8 valence electrons. So yes, step 1 matches how many you've drawn. And when that's the case, you have a good structure. Okay, I'm going to go ahead and stop this video now. I'm going to go ahead and do the examples on a separate video, so go ahead and click on to the second video for the examples.